Hi everybody, I hope you had a wonderful weekend. I am going to go through the notes today and then you're going to get the homework and you can work on that. I'll answer all questions tomorrow, so if you're feeling lost, don't worry. So here is, we're starting exponential equations. So we are going to talk about linear versus exponential. So for linear, here is the same amount per unit of time. So it changes in like 2 and 2 and 2 and 2. So it adds by 2. So here you have a repetition of repeated addition. So these are your two most common linear equations. And like this one was, let's see, we have, I'm still getting used to this. So you started at 5 and it went to 4 or went to 6 at 4. So it increased by 1/4 every single time. So you add 1/4, 1/4, 1/4. Here on the second graph, you started at 6 and it went down 2. So you subtracted or added -2 each time, each unit. So we added 1/4 here. Whoops, that wasn't a 4. And then, or we added a -2 if we're going to talk about just adding. Otherwise, it's the same as subtracting. Okay? All right, so that is linear. We've talked about that for a long time. Here we have exponential. So your equation is ab to the x. So it's repeated multiplication. So you multiply by 2 each time, you multiply by 4 each time, and so on and so forth. So our two graphs, we started, let's see, it's easier to do a 2. So it went up 2 and we went down a certain percentage. So your graph would go, it looks like that. This would be decay, and the second one would be growth. So that's exponential growth or exponential decay. You are multiplying, so in this case, your b would be less, well, in between 0 and 1, so it would be a fraction. Your growth, b is greater than 1. So you're multiplying by something greater than 1. So let's do an example here. Suppose radioactive isotope decays so that the radioactivity present decreases by 10% per day. So first we start with 20 kilograms. So your equation, we start with 20, and you are going to multiply, it decreases by 10%. So if you decrease by 10%, that means you are multiplying, so this is going to be 1 minus 0.1, which is 0.9, to our x power. So let's say it's to the power of 0. So we started with 0. So here's our x and our y. So if we start at 0, anything to 0 power is 1. So that means we just start with 20. And now we take our calculator. And make sure you do this so you know how to punch it in. 20 times 0.9 to the power of 1. And we get 18. And then you do 20 times 0.9 to the power of 2. And you get 16.2. We'll just do one more. 20 times 0.9 to the power of 3, which is 14.58. So it goes down by 10% each time. Okay? Now your graph, here I'm going to, so I have 1, 2, 3, and a 0. So I'm going to be at 20. So that's my 10. And I have 15 and 5. So I'm going to graph 0 and 20, 1 and 18, 2 and 16, 3 and 14. So it's not a big graph, but it works. Okay? So that's going to be decay, because this number right here was in between 0 and 1. So it decayed, so it went down. It's decreasing. Okay? Okay, so it says use the values on the table, write the exponential equation, then find the rate at which each function is changing. So your first job is to find when your y when x is 0. That's going to be your a value. Remember, your equation is y equals a times b to the x. So my a value is going to be 125. So now we have to figure out what is your rate, your b. What changes, okay? What's happening between 125 and 155? Well, the easiest way to do that is to look at another one, and if x can be 1, that's what we want. That's the easiest. So I'm going to erase this here because I'm going to put my y value in, 155 times b to the 1 power. Okay? So then we have b to the first is just b. So 155 equals 125b. Divide by 125. So I need to get out my calculator. And I take 155 divided by 125, and I get 1.24. And that is my b. So then I have y equals my a value, 125, times 1.24 to the x power. So you can put that in parentheses, or you don't have to, it doesn't matter. So that is going to be my equation. Now it says find the rate. Well, this right here...
Adam Eichroven, please come to the main office.
Sorry about that. Alright, so we have 1.24. Well, if we think about that, a 1, if it increased at 1, that means that it would be 125, 125, 125, 125. Well, it's increasing more than 1 because it's getting bigger, so it is growth, not decay. And we are increasing by 0.24. So my rate is 0.24. Okay? So it is more than 1, so it is increasing by 0.24. So my rate is 0.24, 24%. So let's do another couple examples and hopefully it'll make a little bit more sense. Okay, so here is another table. So our first job is to find your a. Well, that's when x is 0. So we have, that is my a equals 900. And then I want this. So remember, y equals a times b to the x. So my a value is 900. b, and then x is my 1 and y is my 675. So all I do is I plug in my y and my x from here, and then my a is from my 0, okay? Right there. So there's all my values. Now I need to solve. So I divide by 900, and I get b. To b, I take 6 divided by 900, and I get 0.75. So my equation is 900, that's what I start with, times 0.75 to the x power. Now, do we see how 900, 675, 506.25, it's getting lower, so it's decreasing. It's exponential decay. So when it decays, we want to see how much it's decaying. So if this was at 1, it would be the same. So it decreases by 0.25. So it's decreasing by 0.25, which is 25%. It decreases by. So the little equation, b equals 1 plus r. So this right here, if you are having trouble understanding that, you do 1 plus r equals b. So let me do a different color. 0.75 equals 1 plus r. So then I subtract 1. So my r equals 0.75 minus 1 is negative 0.25. So it's the same thing. Okay? So both ways, if you understand that it's 25.25 less than 1, it's here. Otherwise, if you need to do your equation, it's up there. Alright, so now for this next one, I want you to see if you can do it on your own. Pause it, figure out your A, your B, and then now your rate. So I want you to pause it and see if you can figure it out. And then push play and I'll talk you through it. Okay, so what I did here, I found my A value, that was when x is 0, and then I put in when x is 1, we have 622.863. So I take that number divided by 621, and my B is 1.003. Now we need to figure out is this increasing or decreasing? Well, we can figure that out by looking at your numbers. Are they getting bigger or are they getting smaller? They're not getting much bigger, but they are getting bigger. So that means it is an increasing function. It is a growth, not a decay. So I put my A times my 1.003 and x, so this is my equation. But now I want to find my rate. How much bigger is it getting? Well, if we look, I'll do the equation so I can help you out here. So let's do r equals 1 plus, sorry, it'd be helpful if I did the right equation. Let's do, alright, so I want the b equals 1 plus r. Okay, so my b is 1.003 equals 1 plus r. And then minus 1, so my r equals 0.003. Now if you could just look at that going, oh, it's 0.003 above 1, so my rate is 1, go for it. But if you have to do this little equation, that is just fine as well. So those are your two, your equation and your rate. Alright? So, good luck on the homework. We'll talk about it tomorrow.